let us talk about the energy stored in a capacitor. Okay. Energy stored in a capacitor. It can be represented by U. Okay. So U is equal to, what is U? The energy. It is given by, that is, half into Q naught square divided by C. Q naught. What is this Q naught? The charge of the capacitor in absence of dielectric, is it not? Without dielectric. And what about this C, the capacitance? And you can put C naught because we are talking about without. Okay, without dielectric, the capacitance. Now after the insertion of, okay, let me put what is Q? Charge of capacitors without dielectric medium. Now Q naught, C naught, capacitance without dielectric. Okay, capacitance without dielectric. Now let me introduce dielectric. Let us introduce a dielectric medium. Dielectric. So the first case is without dielectric. Second case is with the dielectric. We have got some dielectric slab here. Okay. So this is without. This is with dielectric, right? So we have to replace this C naught by C. So U is equal to 1 by 2 Q naught square divided by C on here. Okay. And we already know C is equal to, we have got this equation. C is equal to C naught into epsilon R. So we can introduce this. C is equal to C naught into epsilon naught. Therefore, U is equal to 1 by 2 Q naught square divided by C naught into epsilon naught. So what is C naught? C naught is nothing but capacitance without dielectric. Epsilon naught, permittivity through free space. Okay, right. So that is equal to, and we already know that is this C into epsilon naught. Okay, now is equal to, we can replace this by, and we have got already this equation. Is it not? 1 by Q naught square. U is equal to 1 by 2 Q naught square divided by C naught. Right? So we can replace this by U naught. Is it not? This is U. 1 by 2 into Q naught square divided by C naught. Now this is Q naught square 1 by 2 C naught. Okay? Is it? Is what? 1 by 2 into Q naught square divided by C naught relative permittivity. Correct. Relative permittivity. So above in the theta we can have, that is, this part is U, is it not? Therefore U into U divided by epsilon R. U naught divided by epsilon R, because we have got, no, this is U naught. Okay, U naught. We have U naught. Without means U naught. So it is the energy stored in the capacitor without what? Dielectric is equal to 1 by 2 Q naught square divided by C naught. And let us introduce, now it becomes a U. Instead of U naught, you have to put U. And that is given by 1 by 2 Q naught square divided by C. Now we are replacing this by U naught. Therefore, U is equal to U naught divided by epsilon R. Are you able to follow? So it means that is when epsilon R increases, that is when epsilon R relative permittivity is greater than 1, then what will happen? It reduces the value, is it not? Therefore, the potential energy decreases compared to the potential energy without dielectric. Okay. So it means the capacitor, when we introduce the what? Dielectric, the capacitor spends more amount of energy, is it not? So in pulling the dielectric, okay, inside, and that is why the potential energy comes down. Are you able to follow? So shall we summarize all this together? See, that is, we have got the comparison of V naught. Okay, this is one equation regarding potential, and regarding capacitance we have another equation. Okay, that is nothing but C is equal to C naught into epsilon R, and we have one more equation with respect to electric field also. Is it not? What is that equation in terms of electric field? I already discussed. What is that? The relationship between epsilon R and E naught. E is equal to E naught by epsilon R. Epsilon R. Okay. So we have got this equation. So this is equation 1. This is equation 2. And capacitance 3. And we have furthermore potential energy also. Are you able to follow? So potential energy U is equal to, what is that? U naught by epsilon R. U naught by epsilon R. Okay. So do you have any equation based on Q? Q and the Q naught? C naught into, no, based on epsilon R. So we have 4 important equations. Okay. So you can write down all these equations together. The first equation can be, you can put V. Okay. E. So the first equation is, let me write here. So we are going to discuss now what are the impacts of various parameters by introducing what? Insulation, medium or insulator or dielectric. Is it not? The first one is by introducing an epsilon R, that is relative permittivity. E is equal to E naught divided by epsilon R. So what does it imply? It implies that when E naught is constant, okay, it means by introducing epsilon R, when we increase, this also decreases. Are you able to follow? When it is increasing, when it increases greater than 1. So it means when epsilon R, that is R, this is R, is greater than 1, what happens? E is less than E naught. Correct? Second one, write down these equations. Second equation is when V is equal to V naught by epsilon R, it means that is when epsilon R is greater than 1. So it pulls down the value, is it not? So it means V is less than again V naught, potential difference. And what about capacitance? Third aspect, capacitance, okay, is equal to C naught into epsilon R, okay. So where this implies when C is greater than 1, what happens? C is greater than C naught. Are you able to follow? Okay, it means only in capacitance by introducing insulation medium or dielectric we are able to increase the capacitance, and other parameters are coming down, is it not? Decreases. For example, in the case of potential energy, that is U naught divided by epsilon R, and therefore this implies when epsilon R is greater than 1, then it becomes what? That is U is less than U naught. It means some amount of energy is used up. Okay? So these are the 4 cases you should remember in the case of insertion of dielectric in between the plates of capacitor. Okay?